My name is Daniel Langer. I'm a product manager at Datadog. I'm joined by Michael McClintock, who's a senior systems administrator at Marketo. Just to give a brief overview of what we're going to talk about today, just so everyone knows. I'm going to talk a little bit about monitoring, how we think about monitoring at Datadog, some best practices, what monitoring is all about if you haven't really dug into it before. Talk a little bit about the change from on-prem to these dynamic cloud environments and how monitoring has changed throughout. And then I'll pass it over to Michael, and he'll dive deeper into Marketo's story, their migration from on-prem to Google, and how they monitored along the way using Datadog. And we'll leave plenty of time at the end for any questions you may have. So this is a three-party migration story. It involves Marketo. They're the ones who actually migrated, but Google Cloud was very involved along the way, as you'll hear later from Michael, and Datadog played a part in aiding that as well. So for those of you who don't know what Datadog is, we are a SaaS-based monitoring solution. We collect information from your infrastructure, from your application, from logs. We create awesome time series dashboards and alerts so that you can get notified when things are going wrong and get to the bottom of issues immediately. We have over 250 vendor-supported integrations with all the popular services that you might be using to power your infrastructure. Also, we're hiring, and if you want to learn more about open roles we have, feel free to chat with me after. So not too long ago, I was in Japan, and as anyone does in Japan, they go get sushi. And I went to a pretty unique sushi restaurant in the style of a conveyor belt. And how it works is you take your seat, and there's this big rotating conveyor belt where sushi chefs are preparing sushi and placing it on the conveyor belt, and eventually it comes around to the table in front of you, and you could pick it up and eat it. You could also order specialty items, and the chefs will make it, and it'll come around and make a little sound when it's your item, and you can pick it up. And because I live and breathe and eat monitoring, I started to think, how would you monitor this type of operation? And it got me thinking, and it made me realize that this type of restaurant isn't too far off from a website, right? Or a web server where you're making requests for sushi and you get sushi back, and made me think, wow, this is really in parallel to how we think about monitoring at Datadog. So how do we think about monitoring? Well, we break it into three unique parts. We have what's called work metrics, and these are the set of metrics that are directly impacting your end users. They're things like throughput, successes, errors, how long things are taking. So we think about the sushi example. Throughput might be how quickly sushi is entering the conveyor belt, right? What's the number of sushi pieces entering that conveyor belt per second? What are the number of correctly made sushi pieces versus incorrectly made? And finally, how long does it take for customers to get that piece of sushi after they ordered it, right? What's that latency? And again, these are those set of metrics that are directly impacting your user experience and ones that your user immediately notices. Under the hood, though, there's a set of resource metrics. And these are the things that are powering your system under the hood. So they're things like utilization, saturation, errors, and availability. And to put this into context, utilization might be how busy are the chefs, and how big is their backlog of items that they have to prepare. How many pieces of the raw ingredients do they have? Are they out of tuna? Are they out of rice? How much do they have to work with? Customers might not notice these immediately, right? They're not customer impacting metrics, but they very well might be the root cause of issues. And finally, there's events. These are context-rich sources of information that occur at a point in time. So, I have those examples, a code change. You might be configuring something differently and push a change. You might spin up new infrastructure. Any of these things are events that might have an impact on your operations, right? So a chef quitting, a knife breaking, a machine breaking, any of these things could impact your operations. So we put it into the example of a modern system that you might recognize. We can look at RabbitMQ, which is a popular open source messaging system for sending messages across systems, right? Those work metrics are going to be the ones that your developers or that your end users might actually notice. How big is the queue of messages that are lining up? How many unacknowledged messages are there? Things along that nature. Under the hood, though, there's something powering these queues, right? There's CPU, there's memory, there's network. There's compute resources that are actually powering this queue system. And then finally, there's events that might occur, right? You might push code changes, you might update configuration. All these things could affect the performance of these queues. So great, we're collecting these different types of metrics. We are looking at events. We're centralizing it into one place. But we want to get notified when things go wrong, right? We don't want to notice things on a dashboard hours later. We want to get notified the moment something arises so that we can take action. So how should we think about alerting and notification? So the way we think about it is we want to page or get notified on those work metrics, the metrics that our customers are directly affect the customer, right? The latency, right? The sushi is taking longer to get to customers. Let's get alerted on that. The number of incorrect pieces that our customers are receiving has doubled. Let's get alerted on that. Once you receive those, you can then dig into those resource metrics behind the hood, those ones that are powering the system, and figure out what's going on. And then you could also take a look at the events that have occurred in that time frame, right? Maybe an event caused a change that impacted your bottom line and affected your customers directly. And the reason we think about alerting on those work metrics, the ones that directly impact the customer, and not necessarily the resource metrics, is the resource metrics don't always tell you the full story. So if we think about our sushi example, getting notified that the amount of tuna we have in stock might be useful at 5 p.m. before the dinner rush, but at midnight or 3 a.m., you just got paged for something that might be unnecessary and interrupt your sleep. So we like to think about those customer-facing metrics. So let's talk about alerting in the context of on-premise data centers. These data centers are more static, right? You have a set of servers in a data center somewhere that you've allocated for your application. And when it comes to alerting on those servers, it's a very host-centric ideology. You might write these checks or these notifications when a server is having a problem. So in this example, we have 4 servers running, and we have 4 alerts, right, that notify us when one of each of these servers is going down. At a scale of 4, everything might be okay. You've written the checks, everything's okay. But then what happens if you want to spin up a new server, right? You've outgrown your data center and you've architected a new one. Well, then you have to add a new alert for this server. So let's do that. But wait, actually, we realize we need to spin up one more server, and we need to add one more server to our data center. Okay, so let's add an alert to that. And as you can see, as you continue growing, this host-centric model becomes an extremely manual process because you have to continue adding these host-centric alerts to them in order to have full coverage. And what's more is you only have that really host-centric information. You might get notified that a host is down or a host is having problems or a server is having problems, but then what? That's only a small sliver of the story. You might have an entire environment with databases and web servers and who knows what, but you're only getting notified when the server is having issues. But things are changing. We're moving into dynamic infrastructures where you're writing microservices across regions and availability zones, and using containers that spin up and down and disappear, and you don't always know what's running at one time. So how do you monitor something like this where it isn't static and it's ever changing? The answer is tags. So tags are key value pairs that provide context and information about all the different pieces in your infrastructure. So if we look at the Google console right here, we have a few machines running, and we'll notice a few sets of important information that we consider tags. So we see a zone, we see a machine type, we see a network, and we see those labels that are applied to each machine. All of these are context-rich tags that give us information about the infrastructure itself. And what it lets us do is create data points, right? So we can collect metrics from all these various sources So we can have a metric that might be something like a bytes received. We can have a value, how many bytes we actually received, when did it happen, and then we can add the where did it come from, right? It came from a certain zone. It came from a certain machine type, a host name, a certain role, a team, an environment. And then you can have context around these data points so that you can do things like this. And I want you to imagine each one of these cubes has some data point in it, right? A number that could be the number of errors. On each cube is a set of tags that describe that cube, right? It's a combination of a machine type, a zone, and a role. And these are all machines that might be bundled up. And what you can do is start to group, splice, and dice, and filter this data in a way that's important to you based on these tags. So for instance, if we wanted to get those 3 purple cubes across the middle, we'd say, okay, show me all the data for US East 1A and machine type HiMem2. And it can return you all the metrics for that exact criteria of data. And what does this let you do? Well, one, it lets you move from a host-centric model of alerting to service-centric model of alerting. And I want you to imagine the scenario where you have a group of Google Compute engines that all have some common tag, right? Say it's zone. These are all in a similar zone. And right now, we have one alert that's monitoring all of the machines in this one zone. So if you spin up a new group of instances, say you auto-scale up, you need more capacity, and those machines are in the same zone, well, your alert already covers that, right? It's looking for that zone tag and saying, I'm alerting on all things in that zone. If new hosts get spun up with that same zone, I can automatically alert on them. You don't need to manually add any new alerts. There's nothing to configure. Alerting just works. And if we go back to our small example of RabbitMQ, and we look at it quickly in Datadog, this is an example of creating that type of alert in Datadog. And what we're looking at is the number of messages coming from each one of our queues, and it's only looking in one particular zone, that US central zone. So we have 4 queues there, right? It's split up by name, and if any of the number of messages in any of these queues breaches 10, we get alerted. So if we create a new queue in zone US Central 1B, it'll automatically get applied to this alert group, and you can get notified and take action right away. So that's a brief foray into monitoring, what we think about monitoring, how we approach monitoring, and how monitoring is changing as infrastructure is changing. I'm now going to pass it off to Michael, who's going to talk more about Marketo and their migration journey.
Thank you. Can you all hear me? Yeah? Great. So I'm Michael. I am a senior systems administrator with Marketo. I'm working out of our Dublin office in EMEA, hence the funny accent. I work with Marketo, and we are a customer engagement platform. So what we do is we do marketing automation, and I'm not a salesman, so if you want to know more about customer engagement and how Marketo can help you improve the way you engage with your customers, we have a stand right over there, so you have no excuse not to go on your way out of this talk. What's really important on this slide that you should have a look at is that we grew by 30% with our revenue in 2017, and so that caused us some scaling issues, right? And so we encountered the on-premise issues that you will have heard at talks right across this conference this week. And so we made a decision to move, to partner with GCP and to move our infrastructure to Google. So the sort of issues we were having that we were looking to fix with the move to GCP were scalability issues and flexibility issues. But we were also having some issues with monitoring. So while we investigated and embarked on a journey to move to GCP, we also decided to change the way that we monitor our applications. So the sort of issues that we're having on the monitoring side is that we had multiple tools to monitor the same things. So we had different messages, we had different thresholds, we had different teams who were seeing different noise from different monitoring tools. And that didn't work for us. And so what we decided to do was try and group everyone together and start using Datadog. So what we began with in our monitoring or in our GCP move is that we had to make a decision on how to move our infrastructure to GCP. And so we had this sort of discussion that I'm sure everyone will have considered, which is that we either would take a lift and shift approach, which was to make our infrastructure within GCP work for our application, or we take a transformational approach and make our application work within GCP. And there's loads and loads of upsides and downsides to this, right? There is no silver bullet. There's no objectively correct answer. And what we decided to do is we would lift and shift our application as the first phase of our migration. And so we embarked on phase 1, which is now being completed as part of a 3-phase migration to GCP. So next year when you come back, we can talk a bit more about the other 2 phases. And as part of that, we also got to work really closely with GCP. So we partnered with Google, and we got to work with their CRE team, which has been fantastic. And we got to get Google staff on site to tell us a little bit of best practices of running application in the cloud. If you want to know more about the CRE transition story that we did, tomorrow in the 5th 9 lounge, which is just downstairs on level 2, where we're going to have a talk from Cindy Kim just about that. Why did we go with Datadog? Well, as we started moving away from our own infrastructure, it made sense for us to take our monitoring out of our infrastructure as well. And so a SaaS-based solution worked for us. We also were able to take advantage of those pre-existing integrations within Datadog. And so we were able to get rich, deep metrics about GCP from day one without needing our engineers to go in and create those metrics and start working out ways to record that. And also, we really, really like the custom check writing within Datadog. The agent itself is Python-based, and checks can be written pretty simply. And because you have access to all of the checks that they provided, you get some really good best practice in the code that's shipping and that you're deploying to your servers already. So what we decided to do when we pushed it is we used Puppet to push it across our infrastructure. You could push Datadog out, the agent itself. You could push it within a day. I don't know if you should, right? But you could. You could do it because all you really have to do is push the agent and start the service. And as long as you've got the API key there, you'll see your metrics straight away. And that was really, really useful for us. It was able to give us a situation where we could do a proof of concept with Datadog really, really quickly. And then what we did was, I'll talk a little bit about how we did this later, but we configured our Google Cloud integration within Datadog, which allowed us to start getting information about resources that we were using within GCP. And then we started the arduous journey of converting our existing monitoring solution and moving our infrastructure, our monitoring into Datadog, which involved moving over 1,000 Nagios checks. And if you have questions about how to go through that, absolutely come up at the end and we can talk about it because it's fun. We introduced Google Spanner as well, and this is a really good example of where the Google integration helped us from straight away. So Google Spanner was something that we started using, and thanks to Datadog, we were able to get deep metrics of how Spanner works and what we were doing in our usage of Spanner straight away. So even though we were lifting and shifting all of our applications, on any part of our infrastructure of our application where we decided to do some transformation, we were able to use Datadog straight away and not have to worry about these changes as we iterated our application. So here's an example of, or we could just talk quickly about how you would monitor a migration with Datadog. So thanks to what Daniel was talking about with tagging, we were able to effectively monitor our old infrastructure and our new infrastructure side by side and quickly group by whether a server is in GCP, for example, or what version of code we're running, or which I guess zones and geographical information as well. And what that meant was that pretty much from day one, if you're taking a lift and shift approach, you're able to see how the performance of your application within GCP matches with your performance on-prem. And that's really useful information because you can find out if you're doing something wrong pretty quickly. And you can also find out if it's way better than you were expecting. And here's an example of a dashboard. So you're also able to provide to your engineers pretty much very simply a side-by-side view of your application's performance. Any code changes they push, they can see that straight away. And it's really easy to design, so even I can do it. So other changes that we implemented or other initiatives that we took as part of this move, we decided we'd go down an infrastructure as code route. which meant that we started using Terraform to control our GCP environment. But we didn't want to stop there. We wanted to try and use this philosophy or this approach everywhere that we could. So there is actually a Terraform provider available for Datadog, and what that means is that you can control your Datadog instance with Terraform, which is great because one of the big concerns that we had, and certainly if you're considering Datadog, a concern you might have is that if you have a SaaS solution which is fully managed through a web client, you're worried about who can access it, who can change it, what happens if you lose your configuration, what happens if you click the wrong thing. If you manage this with Terraform, you've got some really good options. So for example, you could just lock down the entire web client and make it impossible to manage the instance through the web client and make all changes go through Terraform. And what that then allows you to do is you can put all of your changes to your Datadog environment through code review. It effectively acts as a DR system as well. If you lose your Datadog instance, you can rebuild it pretty quickly. And it allows you to roll back any bad monitors you introduce, anything that's too noisy or anything that isn't working. And as part of this change, we also changed the way that we handle incident response. So this is an ongoing move that we're making still. I mean, you could have the best monitoring system in the world, but it's kind of useless if it's not paging you or if it's paging you in the wrong way. And so we started working with PagerDuty as well as part of this move. And that allowed us to have a rules-based, really deep, powerful pager routing system. And it allowed us to populate and pass our Datadog tags all the way to our on-call engineer. So as Daniel was pointing out, the tags were one of the most valuable bits of information that we were able to add into our observability. So we were able to take a tag from our servers. So for example, a version of code that it's running, the role that the server is playing within the application. And when we page an on-call engineer or we wake somebody up, we have that information right there, and it's available to everyone. And so this allowed us to really improve the way that we were conveying information to our engineers who are on call. And on-call is not an easy thing to do, or it's not a nice place to be, so it's always nice to make it as easy as possible. So just as an example of the sort of ease of use and quality of life improvements that you get out of using Datadog as part of this, the Datadog cloud integration is really, or the Google Cloud integration, it's really simple to configure. You can do it in minutes, I would say. So all you really need to do is you create a service account within GCP, and you just make sure that you're giving it the correct permissions. I think we have a slide here. It's hard to read, but as long as you've got monitoring viewer permissions within that service account, that account can pretty much start giving you information into your Datadog instance straight away on day one. So you just take a JSON-based private key, and then you go into your Datadog instance, and you just put that key in place, and you will start getting information straight away. And that comes with pre-built dashboards, so you can, within 15-20 minutes of starting to use Datadog and GCP, you can start seeing all of your resources, all of your usage, everything you need on a dashboard straight away. This is an example of the integrations that you get within Datadog. So these are the GCP integrations that they provide dashboards and monitoring for out of the box. But what's really useful is that it doesn't stop here. So Daniel was saying there's 250 plus integrations, which means any application, if you're using an application that's widely used, almost certainly there's some form of integration there. And if it's not there, it's probably on its way. And if you don't see it, it's really quite simple to put that in place yourself.